Hello everybody. Welcome to Objective 1 of our Algebra 8 review. Today we're talking expressions, variables, and order of operations. Okay, some real foundational material here. Basically, if you can do these topics well, it's going to make life easier as you go through the rest of algebra and really math in general. Okay, so important stuff. Let's rock and roll. So first things first, let's give you a definition for an expression. An expression is a mathematical phrase involving numbers, variables, and operation symbols, okay, such as plus, minus, multiply, divide, and we'll have some other ones. Okay, so examples of expressions, we could have something like 3 times 2 plus 7. That is an example of a numerical expression. What we typically want to do with this is evaluate it, figure out what it's equal to. And the big thing with a numerical expression is deciding what order we do our operations in. Okay, do I multiply first? Do I add first? Okay, those will be some things that we talk about as we go through numerical expressions and also algebraic expressions. Okay, an algebraic expression is just an expression with a variable in it. So instead of 3 times 2 plus 7, we could say 3 times x plus 7. Again, we could evaluate this, and the difference between a numerical expression and algebraic expression is this expression will have a different value depending on what my x is. Okay, we can also have some kind of uglier expressions, like we could say 3x plus 7 minus 2x plus 8, something like that. Okay, now in this case, this expression is more complicated than it needs to be. It has multiple x's, multiple constants, multiple numbers in it, and what I want to do is I'd want to simplify it. I'd want to make it look nicer and neater. Okay, so these are all examples of expressions, and then those will be the two big things we do today is evaluate, figure out what stuff's equal to, and then also simplify, clean it up, and make it look nicer. So like we said, when we're dealing with expressions, we need to be concerned about the order of operations, which we'll say is the agreed upon order to perform mathematical operations. So for example, let's go with our 3 times 2 plus 7 expression again, and we want to know what this is equal to. Well, if I do my operations in different orders, I'm going to get different answers. So for example, if I did the 2 plus 7 first, okay, that would give me 2 plus 7 is 9, so I'd have a 3 times 9, which is equal to 27. Okay, but if I do my multiplication first, that's going to give me 3 times 2 is 6, plus 7, which is equal to 13. Okay, in math, I don't want to get two different numbers, two different answers for the same expression, so we better have some rules that we agree upon so we're all kind of doing math the same way. Okay, here's the agreed upon rules. We're not going to get into why they work this way, okay, just because we're not going to spend that much time here. We'll just say it's because they make the most sense. We're going to use the acronym PEMDAS, which stands for parentheses, exponents, multiply, divide, addition, subtraction. So when it comes time to evaluate an expression, we're going to do what's in the parentheses first, followed by evaluating exponents. And then we'll do multiplication and division, okay, from left to right. So we don't necessarily always multiply before I divide. I'm just going to say these have the same precedence, and we'll do them from left to right. And then we'll finish up with addition, subtraction. Okay, again, add and subtraction from left to right. So as far as my quick example here, which one of these is right? Well, I want to multiply and divide before I add and subtract. All right, that's why the 13 is going to be the answer for this expression. Okay, that's an example of correctly following order of operations. So let's take a look at a few problems that are going to make us practice using proper order of operation. Okay, problem 1 just says evaluate each expression. Now remember, when we see that evaluate verb, that just means figure out what number this expression is equal to. Okay, what do I get when I do this math here? And for proper order of operations, we're going to use PEMDAS, which you have right up above this problem of the note guide, so you can refer to that. Again, the P stands for parentheses, meaning that I want to do anything inside of the parentheses first. I want to follow my proper order operations in the parentheses. Okay, so in that case, we'll go 9 minus 5, which is just a 4. So I can rewrite this expression as 2 times 4 to the third. Okay, because what was in the parentheses is 4, and that's still to the third power, plus 3. Okay, notice as I do this, I'm going to rewrite the entire expression every single time. Okay, I'm going to work it down until I get something simpler, until I get the answer. Okay, so we've got the p for parentheses. Next up is e for exponents. Okay, let's talk about this exponent, this 4 to the third here. Let's remind you what that means. Now, 4 to the third means 4 times itself 3 times. So 4 times 4 times 4 times 4. Now, you can plug that into your calculator as 4 to the third, or you could go 4 times 4 times 4. Okay, either way, we get a 64 out of that. So I can rewrite this expression again as 2 times 64 plus 3. Okay, so we've got the p done, we've got the e done. Next up is the m and d for multiply and divide. Okay, we'll take care of any of that first. Okay, I'll do this multiplication first. 2 times 64 is going to give me a 128. And then we'll add, subtract. That's all that's left here. 128 plus 3 is going to give me a final answer of 131. Okay, so as far as answers go, when I evaluate this expression, I get a 131 when it's all said and done. Okay, B, let's do the same thing. Let's do one more as a class just to give you, some more examples before we set you off to work here. Okay, same idea. I want to evaluate this expression. I want to figure out what this expression is equal to. Now, in my PEMDAS, first thing is the P for parentheses. Now, there's no parentheses here, so what I'm going to do is just skip that step, okay, because there's nothing to do with it. Okay, these expressions don't necessarily have to have all the letters from PEMDAS in them. If you don't have something, you just skip that part. Okay, next up is the E for exponents. Okay, so I'm going to take care of this 6 squared here. So my pen just glitched out on me there a little bit. Remember, 6 squared, what does that mean? That means 6 times itself 2 times, so 6 times 6, which I know is 36. So I can rewrite this as 36 divided by 2 minus the 5 times 7. Okay, so we've got the E for exponents done. Next up is multiplication division. Now, we have division and multiplication. As far as which one I do first, the rule says just do them from left to right. And actually here, since they're separated by subtraction, it really won't matter too much. But anyways, we'll go 36 divided by 2, which will give me 18, minus 5 times 7 is going to give me a 35. Okay, so we've got the multiplication and division done. Last step, addition, subtraction. Again, do them in from left to right. We've got subtraction here. So if I go 18 minus 35, I'm going to get a negative answer. We'll say negative 17. Again, a reminder, anytime you have a smaller number minus a bigger number, your answer will be negative. So we get a negative 17 there. Okay, so there's a few examples of using proper order of operations. In your note guide, you're going to see a part C and D, 2 more practice problems. Pause the video here, work through those questions, throw a hand up in the air and get those questions checked. Make sure you're doing those correctly before you move on. And then once you have things checked, move on to the next part of the video. Next thing we're going to do with our expressions is add variables to them. Now, a variable is just a symbol that works as a placeholder for a value that can change or vary. So again, for example, with my simple expression, if I have something like 3x plus 7, okay, this x can take on any value we want, and what this expression is going to evaluate to is going to be different depending on what that x is. Okay, so I can't actually evaluate this expression as it is. Okay, but if I had a specific value for that x, like a 2, we know it's equal to a 13, something we've done before. Or if I change that value again, so we could say 3 times, let's say 5 plus 7, I'd get something completely different, okay, depending on what this value is. Let's see here, 15 plus 7 would be 22. Okay, so that's the idea of a variable, is it's a placeholder where we can fill in any value we want for that variable. So let's go ahead and take a look at some expressions with variables mixed in. Problem 2 says evaluate each expression for c equals -3 and d equals 5. Once again, evaluate just means figure out what each of these expressions are equal to. And notice they both have some letters in them, some variables. We're going to evaluate these expressions for these specific values of those variables. Okay, we'll do a couple of these together before we set you off to practice. Okay, so let's go ahead and do part A first. Now, part A has a single variable in it, just the c. Okay, I'm going to say that c equals -3 for this problem. So we can rewrite this as 1 plus, and when I fill this in, I'm going to put in parentheses just to start off with. Okay, I'm going to replace that c with the value that c is, the -3 in parentheses. Whoops, and I almost missed my squared here. We'll rewrite that. And then from there, I'm going to start simplifying. I'm going to show more work than I need to, but just trying to explain everything here. So what I have in parentheses here is really a 1 minus 3 squared minus 3 squared. Okay, then once we have those variables plugged in, we're really back to the same spot we were a few minutes ago, just evaluating expressions. I've gone from an algebraic expression with variables to, once the variable's plugged in, just a numeric expression. So now what I'll do is I'll just follow order of operations to figure out what this expression is equal to. Okay, PEMDAS, inside the parentheses first, 1 minus 3 is going to give me a -2. So I have -2 squared minus 3 squared. Okay, now side note again real quick, -2 squared is going to be equal to -2 times -2. Now I know that a negative times a negative is positive, so the result here should be positive. Okay, 2 times 2 is a 4, so it should be a positive 4. Okay, a good rule of thumb is that anytime you square something, you should get a positive answer out. Now if you want to square something negative on the calculator, the trick is you've got to put both the number and the negative into parentheses. Okay, that'll give you that positive result, that positive answer when it's all said and done. Okay, so the -2 squared is just a 4, so we have 4 minus 3 squared, which is 3 times 3 is 9. All right, 4 minus 9 is going to give me a -5. All right, so when c is -3, this expression will evaluate to, will be equal to a -5. Let's go ahead and run through one more example of this together here. Just divide my workspace up. Now, same idea. This time I'm going to be plugging in or substituting in the values for 2 variables in my expression. And so I have cd squared. Now, when you see 2 variables written next to each other, the multiplication is implied. So we've got c times d squared. And once again, when I go to fill things in, I'm going to use parentheses. So my c is a -3. Okay, times my d then, which is 5, so we'll go parentheses 5, and that's squared, okay, with the plus 4. So we've got stuff substituted in, and again, I like to use parentheses for my placeholders here just to keep things neat and organized. Again, from here, we're back to a numerical expression. We can evaluate it with our proper order of operations. Okay, PEMDAS, P, there's no parentheses here. Okay, no evaluation to do in the parentheses, so we're good there. E for exponents. I want to take care of my exponents next. So we're going to do 5 squared. 5 squared is just 25. So this will be the negative 3, okay, times a 25 plus 4. Okay, then next, multiplication and division. Negative 3 times 25 is going to be a negative 75. Suppose I'll keep my equal signs going here. And then negative 75 plus 4 is going to give me a negative 71 for a final answer. All right, so that's what that expression evaluates to. Once again, there is a part C and D, okay, for this problem too. They have different values for the variables, so make sure you're not using the negative 3 and 5 again. Use the ones given in the note guide. Pause the video. Take a few minutes to work through those. Shoot a hand up, get your answer checked before we move on, and then you can continue with the video. Next thing we're going to do with expressions is work on going from a description or a word phrase to an expression. Now, come time for real-world math, it's going to be very important to be able to put that real-world situation into our variables, into our expressions. Okay, we're more focused on the skill part of things here. Okay, we don't have time to do everything. We won't get into a lot of real-world situations. Okay, but again, important skill to have. So problem 3 says, write an algebraic expression for each word phrase. And we'll do 2 of these together here. First one says 5 more than the product of 3 and a number x. Okay, when you see the more than part of a phrase, that just means plus. Okay, so we can think of this 5 more than as just plus 5 showing up as in our expression. Okay, if we said less than, that'd be a minus. And then when you see product, think times. Okay, so the product of 3 and a number x, in other words, 3 times x or 3x. So when I go to write this answer out, 5 more than the product of 3 and x, I can just say 3x plus 5. Okay, 5 more than the product of 3 and x. It'd be equally correct to write that as 5 plus 3x. Okay, or we could say x times 3 plus 5. That would work as well. Okay, it doesn't matter what order we write these in. This is probably the way we're going to be most used to seeing it, but any one of these would be correct. All right, let's do one more of those. Okay, the quotient of 4 less than a number n and 7. Okay, when you see quotient, that just means division. Okay, the quotient of 2 numbers means to divide those 2 numbers. And when I see the less than here, think subtraction. Okay, now the trick with this one, how it's going to work out a little differently, is we have the quotient of 4 less than a number n and 7. Okay, so it's the quotient of all of this stuff here and 7, meaning the way we can write this as 4 less than the number n, so in other words, n minus 4, and we're going to divide that by 7, so what I can do here is I can write all over 7. Okay, or it'd be equally correct just to write it as n minus 4 in parentheses divided by 7. Okay, but typically we'll write things in the fraction form. It's a little easier to work with this when it comes time to evaluating, when it comes time to solving equations, than it is in this form here. Okay, there's a few examples. Problem 3 also has a part C. Why don't you take a minute, pause the video, work through that one, and check your answer before we move on once again. All right, so the next thing we're going to do is just the exact opposite of what we just showed you how to do. In the previous example, we went from a word phrase to an expression, to an algebraic expression. Here we're going to go from algebraic expression to the word phrase. Okay, so problem 4 says, write a word phrase to represent the algebraic expression. So we have 6 over x minus 9. Now the trick is kind of identifying the different parts to this expression. Now, I'm seeing 2 of them. The 6 over x, we could write that as the quotient of, not or. Okay, again, we'll call division the quotient of, we could say 6 and x. And then this minus 9 part, we can write that as 9 less than. Or we could say subtracted by 9 if we want to switch the order up. But probably the simplest way to put these together, and kind of the best sounding way, would just be 9 less than the quotient of six and x. Okay, now there's some other ways we could word this. We could say the quotient of 6 and x subtracted by 9, or 9 minus the quotient, or I suppose I couldn't do that. The quotient of 6 and x minus 9, yep, like I just said there. Okay, but I think this is probably the most straightforward and kind of most consistent with, the way we're looking at the rest of these problems. Okay, that's part A. Once again, there is a part B. Pause the video, go ahead and work through that one, and then check your answer before you move on. All right, the last thing we're going to look at today is a few different examples where we're simplifying expressions. Okay, it's very common in the math classroom or in the real world when you're putting your expressions together to end up with the same variables showing up multiple times. So for example, here I've got multiple terms that contain the x's. Okay, only one y, and also multiple terms that are constant with just the numbers to them. Okay, we want to clean that up. We want to simplify that expression. So when I say simplify, what that means is to rewrite the expression as an equivalent expression that means the same thing, that just looks nicer, that just has some things combined and evaluated, okay, making it look as nice as it can. Okay, so let's go ahead and simplify this expression. Now, I'm not evaluating it. Since I'm not given values for the variables, I can't say that this expression equals some number. What I can do is say it's equal to a nicer expression, and that's what we're going to figure out here. Okay, so first thing I can do is notice there's two different terms with x's in them. There's a 5x and a negative 3x. Okay, 5x minus 3x. Okay, 5 take away 3 will be 2. So I can simplify that down to a 2x. Okay, and then from there is a 6y. Now there's no other parts with y's in them, so there's nothing to combine this with. And x and y are not like terms, they're not the same thing, so I can't combine these. So the simplest I can make that part is just say plus 6y. And then the last thing I can do is combine my constant terms. I have a negative 3 plus a 4. Negative 3 plus 4 is just a 1, so we can say plus 1. Okay, I'd say that this is my simplified expression here. I've got all the x's combined, I've got all the y's combined, I've got all the constants combined. Okay, again, I can't evaluate and say it's equal to a number, okay, but this is equivalent to this expression. It just looks a little nicer. It's simplified. Okay, that's the basics of simplifying an expression. I want you to hit pause on the video, give part B a shot, get it checked before we move on. Next example we're going to look at is an expression involving a fraction. Okay, or another way we could think of this fraction is as division. 15xy divided by 3x. Now, as we go through algebra, we're going to see all kinds of, we'll say, crazy fractions with different exponents, different expressions in the numerator, denominator. We'll say this is kind of our basic case to start off with. And the idea is the same. I want to combine my constants. I want to combine my liked variables and reduce it down and make it look as nice as possible. Okay, so for this one here, what can we do? Well, we can reduce this fraction, the 15 thirds. Okay, 15 divided by 3 is just a 5. So that part reduces down to a 5. Next up, we can look at the variables. Now there is x's on top and bottom, so I can reduce that as well. Okay, we can think of this as x divided by x, and I know that anytime I divide something by itself, I get a 1. Okay, so essentially if you have an x on top and bottom, or any other type of variable, you can really just cancel those out. Those will go away. We don't need to do times 1 here. Okay, we don't need that piece. All right, last up we have the y. Kind of like with our last example, there's nothing to combine that with. So I can say this kind of ugly looking expression here with a fraction reduces down just to a 5y. All right, once again, you have a part B. Pause the video, work through part B, and then get your answer checked before you move on. Next problem we're going to look at is simplifying expressions involving the distributive property. And let's take a look at what we mean by that. So with this expression here, I've got 5 parentheses 2x minus 3. Now when you see a number written next to parentheses, the multiplication is implied. Okay, so it's 5 times the quantity of 2x minus 3. And now if I was following order of operations, what I'd do, and if I had a specific value for my variable x, is I'd plug that in and then I'd do what's inside the parentheses first before I multiply. So I do the 5 times kind of the result of what's in the parentheses here. Now since I don't have specific values for that x, I can't do that. So the best I can do is I can distribute the 5. I'll do 5 times the 2x, and then combine that with the 5 times the negative 3. In other words, I'm going to multiply 5 by everything in my parentheses here. Okay, so doing that, we'll go 5 times 2x. Okay, 5 times 2 is 10, so I can write that as just 10x. And then also 5 times negative 3, which will be a negative 15. So we can say just minus 15. Okay, so again, that's 5 times everything in parentheses here. And then we've still got the minus 3x here tagging along. We'll write that out here. And then I'm going to say once you've used that distributive property, you're back to kind of the simpler question we started off with a few examples ago. Now I can just combine like terms. 10x minus 3x would be a 7x. So I can finish this off by writing this 7x minus 15. Okay, for my final simplified answer. Okay, part B is another example of using the distributive property. I want you to take a minute, pause the video, run through that example, and check your answer before you move on. Last question we're going to look at is simplifying expressions with exponents. And when I say we have exponents involved, notice we have an x squared in 2 different parts here. So this is just like our basic example where we're going to combine like terms. But the trick for it is recognizing that x squared can be combined with x squared, but I can't combine my x squared with a regular x if my variables don't have the same powers or don't have the same exponents to them. I can't combine them. Okay, so 5x squared minus 2x squared is going to be a 3x squared. Okay, we'll add and subtract the numbers out in front of the variables just like we would if they were regular x's. Okay, the plus 3x, all I can do with that is write it as plus 3x. Okay, this is just like if I had a 3x and a 3y, I couldn't put those together. Okay, again, an x squared and an x are not like terms. And then last step I can do is combine my constant terms. I've got a positive 8 and a positive 6. 8 plus 6 is going to be 14. And that's going to be as simple as I can make this one. Okay, again, I can combine the variables if they have the same exponents on them. I can't combine them if they don't have the same exponents. Okay, one more time today. Pause the video, or I suppose the video's over, so stop the video, work through part B, get your answer checked, and then you can start getting into the practice problems on Math XL. Okay, we'll see you folks next time here.